Alright, so today we have a Wells Gardner U2000, and this was sent in because recently purchased from eBay. It was working fine, then one day you turned it on and it had vertical collapse. When I went to remove the chassis, I could smell something burnt. I pulled the chassis and found a burn mark on R760 and Q708. So R760 and Q708 are these guys right here. And if we zoom in, not sure why it does that. Maybe it's too quick. Okay. If we look here, we can see 760 has obviously been either reworked or replaced, and here's Q708. And the backside here has definitely some rework. So this was burned before any of this happened. So I don't think this having a burn mark here and everything is indicative of the collapse, because this has been reworked in the past. Most likely because the HOT was blowing on the U2000 and the U5000. If your HOT is constantly blowing, you could have an issue with either 760 or 765. I think that's 765. Yeah, one of these two here could be open. If either one of these two are completely open, then your HOT is going to keep blowing like that. But if we just give it a good cursory look over, our linearity coil is not broken, but it's loose off of the foundation, which they all are from shipping, which we can glue that back in place, not a big deal. As long as the magnet is still attached to the coil, this can be in any position it wants to be, and it won't affect the image. If the magnet is loose off the coil, then it'll affect your linearity. Q703 has been replaced with one that's not the right type. I mean, I'm sure it might work, but it's not the right kind, so that's not original. That's been replaced. Let's get rid of this. And yeah, it's been changed out. So, okay, vertical collapse. Well, the caps are all the original except for this one. This one's been replaced. C725 has obviously been replaced. It looks like possibly C729. I don't think so, but that's original. These are original. That's original. That's original. Maybe a partial cap kit, because this one's been changed as well on the neck board. So it's hard to say. There's been some pots replaced. This one most notably, and also on the remote board. The horizontal hole's been replaced. But doesn't appear to have any broken pots, like your vertical hold and vertical position and vertical size, which is labeled height. You can't see it, but it's important to check the easiest quick stuff like that. Like, none of the pots are broken. The connector and harness appear to be okay. Let's look at the solder joints on that. Yep, that's all okay for your connection. So it doesn't appear to be a connection or a pot issue that might cause it. Especially since it just all of a sudden went to collapse. Oops, dropped my tweezers here. Okay. Well, a general cursory look over, everything seems to be okay. Someone's changed out the RGB encoder chip here and put it in a in a socket that they cut off and got from somewhere else. Not a big deal, but alright. And we got, of course, the regular loose. These two are secure, but this one's loose. These two are secure, that one's loose, and we can see that the pads are broken. Not a big deal. That won't cause collapse. Alright, well, let's disconnect this and get some of this stuff out of our way here so we can work a bit easier. Okay, neck board is out, remote board and harness are out. Okay, so for collapse, the easy things you want to check are R303, D302, D603, oh, sorry, you can't see. D603, this little diode in here, R303, D302, and the vertical IC itself. Now, ideally, what we should do is plug this up onto a tube and verify the discrepancy to make sure that it's not something with the owner's yoke or tube or something. But we'll go ahead and just test everything, and if we find nothing wrong, then we'll go ahead and do that and see if maybe it's an error on their end. But Yeah, so ideally you'd hook this up and test for your 25 volts. There's a test point right here. It says plus 30 volts. Oh, and dropped them again. Okay. So right here there's a test point, plus 30 volts. So with this up and running, you go to that test point, you should have around 25 volts. If you have 25 volts, then all of your circuit is good from the flyback through all your components here, R303, D302, D603. If all that's good and you have your 25 volts, then it's likely a bad vertical IC, which is this one right here. So what we can do is let's just do some initial testing on those early components here. I'm not worried about, I'm not sure what the burning smell would have been, but R760 is not burned up, and the char marks and stuff is from previously burning up, not this time. So I don't think that's the issue. It could be, I could come to regret that, but I don't think that's the issue. So let's just check R303. It should be 1.2 ohms. That is this guy right here. If we could get the flyback to get out of our way here. Sorry, should be on ohms. 1.4 is good. D302, let's make sure it's not shorted or open. And it is good. 0.4 voltage drop. That's okay. That's for our video B plus 1.6 and 1.3. Yeah, see, that's all okay. Let's test D603. D603 is this diode right here. Now, negative on the side with the stripe, positive on the side without the stripe. In your diode mode setting on the meter, it should not read both ways. If it reads both ways, then our vertical IC is bad. So we'll test it the way we're supposed to. It should be 0.6 voltage drop. And 0.5, close enough, I guess. Usually it's around 0.6 voltage drop, but 0.519 is okay. And now I swap the leads. It should not read the opposite way. And it does read the opposite way. Our vertical IC is most assuredly bad. So now if we go to our vertical IC, we should only have one pin that reads to ground. And that should be this pin right here. I believe it's pin number 5, because pin 1 is all the way to the left. Yeah, pin 1 is all the way to the left, so this way it's all the way to the right. So if we go to ground and we go at a 10, well, that's bad already. This one here should be ground. See, 0 ohms, 0.2. Now here's pin 10. 24 ohms to ground is not good. 9, 10 ohms to ground is not good. 8, 96 ohms to ground is not good. So, wow. 10, 9, that's too high to go for ground. That's supposed to be ground. Yep, we have a shorted vertical IC. Now the question is, why is the vertical IC shorted? Did something else short it out? Because we certainly don't want to put a new one in and have it short out. But the burning smell most likely was just a vertical IC burning up, or I don't know what would have caused it. So I think because these caps are all original, what I'm going to do is I'm going to do a full cap kit and a full reflow and test some other components. But yeah, there's not really any reason to even turn this on until we replace the vertical IC. So yeah, I'm going to do a full cap kit and a full reflow, full inspection, glue this back down in place, do all the normal work. Obviously we know it powers up and operates because it was working, it just was collapsed. So even though Q703 is a different type, we know it should be working. HOT should be working. I don't think it's an issue with the R765 and 760 because I think I may have referred this to as 65 earlier, but it's R760. We know that's okay because otherwise the HOT would be blown. Yeah, so I think what we'll do is I'll just do the cap kit and the reflow and the inspection, glue this back down, and then I'll come back and we'll replace, after I do that, we'll replace the vertical IC on camera. All the rest of the work I won't do on camera because I've got, you know, video after video after video after video of doing all that stuff. So I'll do all that, and then we'll change the IC out on camera and verify after removing the IC that pins 9 and 10 no longer read to ground. If they do, then something else is wrong. If they don't, then then we should be good to go. But it's a very quick and easy way to tell if your vertical IC is shorted. If D603 reads like a diode both ways, the IC is bad. If it only reads one way, the way it's supposed to, the IC should be good. But I've had vertical collapse before where the IC read properly, D603 only read one direction, none of the pins were shorted, everything read okay, I had my 25 volts, but I had no deflection because the IC, instead of being shorted, was either open or not working properly. So you can still have a bad vertical IC if it doesn't read, even though it reads okay and nothing reads bad, it can still be bad. And those are the troublesome ones to try and figure out. But in this case, we have to worry about if it's something else on the chassis that took it out or it simply failed. But in this case, yeah, we'll take it out completely, and if pins 9 and 10 read open to ground, then it likely just simply failed, and it happens. So, all right, I'm gonna cut away here. When I come back, I'll have all the cap kit and reflow complete, and then we'll change this out, make sure it's not shorted anymore, and then we'll try it out. So here we go. Okay, so just like that, full cap kit reflow inspection is done. Didn't notice any anomalies. Then we have the neck board is all the same, rebuilt, reflowed, inspected. I got all the solder joint, I'm sorry. I got all of the solder removed from the transistors and cleaned the pads, put new solder on there. Got all of the resistors lined up and reflowed as well. Everything that I normally do to these is done. All of the color pots have been wiped back and forth a bunch of times and set back to the middle position for a good baseline of color. All of our transistors are now secure, so nice and tight. So they're also aligned and back to factory fresh condition here, so to speak. So yeah, now what we'll do is we will replace our vertical IC and make sure it's not shorted and all that, and the pads, I mean, once it's out of the circuit. And I only have one left. I got one left, so hopefully it doesn't blow up. So let's see if we can get this guy out of here. All right. And let's zoom in a bit. Okay. Gonna have to use the iron for this one. It's a large pad. There we go. It should be loose. All right. And on down the line we go. I just like to use the iron to do this because it just makes it so much easier. Well, that doesn't seem to want to. That one doesn't want to clear out. So we'll use the braid for that one. If it wants to be stubborn, that's fine. Okay, I think that'll work. Now we can turn that off so it's not so loud. And then use the braid on that one. Alright, there we go. And it should come right out. Assuming, well, hang on, let's hit this one here. Okay, now, barring any unforeseen circumstances, should come right out. Well, it's loose. It's just, there it is. Easy peasy. So the first thing now is let's grab our meter again. And let's make sure that our pins 9 and 10, or pads 9 and 10, don't read to ground. So again, we got our meter. Alright. So this should be ground here. Pin 10, open. Pin 9, open. And if we go to here, the only one should be, wait a minute. Well, yeah. There's your burn. There's your burning smell. Look at that. That is cooked. And it actually leaked out something from the inside. This whole area is cooked. It may even be cracked. So absolutely, this is our problem. Now, whether or not it simply failed or something caused it to fail, that will remain to be seen. So if we go to the frame, should be what? I think it's, there it is, 0. 0. Yeah, pin 9, or I'm sorry, pin 10, 24 ohms, pin 9, 10 ohms. There's our ground. Yep, that guy's a goner. So we'll set that aside and see if we can get our replacement out here. Ah, there we go. Okay. Now if we do the same to this one, turn it around, this should be our ground, and no other. There's pin 10, pin 9, 8, 7, there's our ground. 6, 5, 4, 3, 2, 1. Okay, so let's get this sucker installed. Hopefully just goes right in. Right in. How about that? It doesn't need to be super tight, just secure. And let's get this soldered back in. Alright, there you have it. Didn't create any bridges. That looks pretty darn good, I must say. So here we go. Let's touch ground. We should have pin 6 to ground, 10, 9, 8, 7, 6. Oh, come on. Oh, I'm sorry. This way. 10, 9, 8, 7, 6. Sorry, we're upside down. 5, 4, 3, 2, 1. All right. Well, okay. I think that about solves it. So let's go get a picture tube, get this all hooked up, get this all back together, and see if it works. Oh, I forgot to mention that this did not come with the little cardboard protector for the back, but it's supposed to be there. So I actually found one that's actually for a U2000 and installed it. Believe it or not, I have like 1,000 of these things. So I grabbed one that was supposed to be on a U2000, got it on there. So that's back to the way it's supposed to be. And get out of here, you rotten neck board. Get off of there. Okay. Let's get it on a tube, cross our fingers, and see what happens. Well, and just like that, we are hooked up to the tube. We have our anode, neck, yoke, ground, power, video, remote, the critical 7. So let's turn this TPG on, and we're set up with the meter to read our 30 volt reference, so we're hoping to get 30 volts. If we do, then we know our vertical deflection circuitry is good, and it was just an issue with the vertical IC. Now, if something takes this one out immediately, we'll have to go back and look and see what else is wrong. But the original note said that it worked for a while, and then the IC crapped out. So I'm going to let this run for a number of hours just to make sure that nothing goes bad. Make sure it doesn't overheat, make sure the heatsink isn't abnormally warm, things like that. But that'll be outside the scope of the video. This is just going to see, this video is just to get the issue fixed, which hopefully all it is the IC based off of our testing. So after the full reflow, rebuild, cap kit, neck board rework, and everything I normally do, all signs point to it should work, especially since we know for a fact the old vertical IC was shorted, and it's just chilling right there, burned up and shorted. So TPG is on. Let's turn our volts on to volts DC, and we got 0.012. So we're going to turn this on. Hopefully we get to 30. If we have full deflection, everything seems to be okay. I'll hook up to the B plus setting and make sure our B plus is 117. But for now, here we go. 1, 2, 3. Okay, it comes on like we know it would, and they are 28 volts. Do we have deflection? The flyback is too high, but holy crap. Look at that, we got full deflection, but it's super tall. Let's lower our height. There we go. Awesome. Let's get the camera on the tripod and go through all of our adjustments. Alright, so let's go through the adjustments here. Let's start with contrast. Well, hell, brightness is all the way down, so that's, the flyback's way too high. Contrast all the way down, brightness all the way down. Let's get our adjustment tool here and let's turn our flyback down, because that is way too high. Let's go right there. I think that'll work. And let's do contrast. Hey, brightness. Contrast down, brightness up till the back. See how the background is not black? So turn it down till the background is black, which is right there. Supplement with contrast. Beautiful. Okay. Width is way too wide. H position. Width right there. Vertical position. Vertical height. We're a bit too green, but that's no big deal. Right there. A little bit more brightness. Well, look at that, ladies and gents. That looks pretty darn good. Let's scroll through. Nice. Beautiful RGB, nice, sharp, and crisp. Look at that. Wow. All right. Well, we're sitting at a comfortable 28.32 volts. We have full deflection. Heat sink is lukewarm. It's not getting too hot. I'd say we have a successful repair. So I'm going to chalk this up to just simply a component that failed over time, which happens all the time. And I'll let it run for a number of hours. Usually I do about 2 or 3 hours, but given that this worked for a while and then went into collapse, I'll give it a much longer period of time, maybe 8 hours or so. Even that's kind of getting a bit too long. If it's going to crap out, it's going to crap out before 8 hours, but that's why I just normally do about 2 or 3. Anything that's going to burn up and die is going to burn up and die within a couple of hours. So yep, I'll let this run for at least 8 hours, make sure it doesn't go bad, because I don't want to give this back to the owner and have him run it for 8 hours and have it go bad again. So, but for the scope of this video, we have a successful repair. I think our vertical IC simply just decided to give up the ghost over time. So it did not look as if it had been replaced. So no, that's about it. I'll go through, do some more testing and make sure nothing is going to explode and do various other things, but for the scope of this video, we have a successful repair. Thanks for watching. Got a couple more on the way, so stay tuned for those. Otherwise, I appreciate it. Make sure you like, share, and subscribe, and comment, and we'll see you next time.